Okay, we made it to the next page of the notes here, and I don't want to spend too much time on this page because we will have an entire chapter later on in the book dedicated just to polynomials. But there are a few things, again, that I just want to refresh your memory on before we get too far into Algebra 2 here, just so that when we start using some of these terms and definitions, you're familiar with what they mean. We're going to talk about polynomials, and a couple of things about polynomials. A polynomial is named based on the number of terms that are in the polynomial. So you can see here I've given you a couple of names. There's a monomial where it's a single term, binomial, of course, meaning 2 terms, trinomial, meaning 3 terms, and any polynomial that is 4 or more terms, we're just going to call a standard polynomial. But what I really want to point out here when it comes to polynomials is this. When you have a polynomial, in order for it to be a polynomial, there's a couple of things that have to happen, and here's what they are. It must be a finite sum of terms. What this means is that polynomials cannot be infinite. They must come to an end. All right? There has to be an ending point. It's only a certain number of terms, and then it has to stop. Also, variables, the variables in the polynomials must have whole number exponents. What this means is you cannot have exponents that are fractions. Yes, believe it or not, later on in the year we are going to deal with fractional exponents, but not with polynomials. All right, polynomials must have whole number exponents, no fractions. And finally, no variables are allowed to appear in the denominator. All right, so when we're trying to figure out is something a polynomial, you're looking for those 3 things. It must end. It must be finite. Exponents must be whole numbers. All right, they can't be negative, and they can't be fractional exponents. And finally, the variables are not allowed to be in the denominator. So what I've got for you is I have a few examples here, and let's just go ahead and take a look at these examples. I've already told you which ones are polynomials and which ones are not. So let's just run through and look at a couple of things that might throw you off that I want you to be aware of. And then, of course, what we'll do is we'll go through and figure out, based on the definition, why are these ones not polynomials. So here we go. In the first one, what we've said is that this is a polynomial, and it should make sense. It's a binomial. There are 2 terms, 3x squared and the plus 3 being the second term. There's nothing that should be out of the ordinary there. I'm not dividing by a variable. My power is a whole number, and it ends. It's only 2 terms, right? It's a finite sum of terms. The second one, though, might be the one that could possibly throw you off. I know that I said in the definition that you're not allowed to have fractional exponents, right? Must be whole number exponents. You're not allowed to have a fraction as an exponent, but that doesn't mean that you're not allowed to have fractions in the polynomial. You absolutely can have fractions. They just need to be the coefficients that go with each term. So my first term is a 1/3 x squared. Perfectly okay that my coefficient is a 1/3. My x is the variable, I'm not dividing by it, and my exponent is a whole number. So we meet the definition for a polynomial. Down here in this one, again, it is a polynomial. It turns out to be a trinomial. I have 3 terms, and the leading coefficients in 2 of those terms is negative. Perfectly okay, as long as I'm not dividing by a variable. My exponents are whole numbers, which they are, and it has to end. And it does. I only have 3 terms. And then finally, the last one, I don't even have a coefficient with my first term. That's okay. There's an implied 1 in front of that y. Just remember, anytime there isn't a number written, there's an implied 1 there. And of course, I've got whole number exponents, and I'm not dividing by a variable. Now, what I want to do is take a look at these ones over here, the ones that are not polynomials, and we need to figure out, or I'd like to figure out why. What about the definition does it not meet? Now you should be able to see pretty clearly here in the first one that what has happened is you're dividing by a variable. Please notice that the x is in the denominator. That is division by a variable and it's not allowed. What might be throwing you off is this one. I have 1 over x, or x to the negative second. Let me show you real quick what x to the negative second means if you haven't, or if you don't remember this from Algebra 1, because you did actually look at these in Algebra 1. So let me write it again real quick for you, right down here. It is x to the negative second plus 7x. Now, the rule about exponents that you learned in Algebra 1 is this. Anytime you have a negative exponent, you can make that exponent positive by taking the variable to the denominator, which is exactly what we're going to do. So I'm going to put a 1 over, and I'm going to move this x to the negative second to the denominator of this fraction. And when I do that, the sign on the exponent changes. So now it will be an x squared, and I still have my plus 7x. Now again, if you don't specifically remember this rule from Algebra 1, don't worry, there's an entire chapter on exponents in Algebra 2 as well. We'll review all of that. But what you should see here is that 1 over x, or x to the negative second, which actually means 1 over x squared. They both fail to be a polynomial for the exact same reason, and that reason is this: you are dividing by a variable. So, for the exact same reason, these guys are not polynomials. You wind up with division by a variable. What about the next one? Well, the next one should jump off the page at you. We know that it says in our definition they must be whole number exponents, and in this case we do not have whole number exponents. They actually are fractions. So we'll just simply put fractional exponents. I'll abbreviate exponents EXP. Now, in the next one, again, you may not be familiar with what the ... at the end means. Here's all it means. It just means that this guy, this whatever it is, this expression, turns out to be infinite, okay? We actually can see the pattern. I have a 1, and then plus 2x, plus 3x squared. It would make sense the next term would be 4x cubed. The one after that would be 5x to the 4th, then 6x to the 5th, and so on to infinity, which we know our definition says is not allowed. Polynomials must end. They have to be finite. They cannot keep going on to infinity. Because of this, it is not a polynomial. This guy is not finite. Therefore, is not a polynomial. Now, the next one, the last one here, again, may look a little different. You may or may not have gotten to radicals in Algebra 1. That's okay, not that big a deal. Again, we have an entire chapter on radicals here in Algebra 2. So I don't want you to fret too much about what I'm about to do. If you don't really understand how it works, that's okay. Just know that radicals cannot be in a polynomial, and let me show you why. Once again, let me rewrite it. The square root of 9 minus x. Here's what I want to tell you. The way this works is that a square root is actually an exponent. It turns out to actually be the exponent of 1/2. And let me prove it to you. If you happen to have a calculator handy, go ahead and take the square root of 4. Of course, if you take the square root of 4, your calculator is going to tell you the answer is 2. Using that exact same calculator, go ahead and do 4, and raise that 4, please put it in parentheses, raise that 4 to the 1/2 power. Your calculator, once again, when you do 4 raised to the 1/2 power, is going to give you an answer of 2. The reason is because square root and 1/2 power are the exact same thing. They mean the same thing. Instead of writing a fractional exponent, we just simply write it as a radical instead. But now we know what the problem is. Our definition says exponents must be whole numbers. I don't have a whole number exponent. The radical tells me that I have a fractional exponent, an exponent of 1/2. So once again, in this one, we have a fractional exponent. That takes care of everything on this page. Head on over to the next page of the notes, and I'll meet you there.